CCI, Crash Course Instrumentation, presents episode number 23, Level Switches. Float and Tuning Fork. Goal: understand how float and tuning fork level switches work, when to use each, and how to mount, wire, and test them so they alarm and control reliably without nuisance trips. Credit: thank you to Tony Kuphaldt and the open source community for empowering Crash Course Instrumentation. Opening hook. If your sump pump short cycles or your tank overfills even though the alarm is working, your level switch choice, or installation, probably needs love. Today we'll make float and tuning fork switches behave like pros expect. Jargon decoder, used in this episode. Discrete switch, a simple on-off device that changes state at a set level. Float switch, a buoyant device that rises or falls with liquid and changes a contact when it tilts or moves a small magnet. Tuning fork level switch, also called vibrating fork, a metal fork that vibrates at a set frequency. Liquid touching the fork changes that vibration and flips an internal electronic switch. Deadband, or differential, a small gap between the point where the switch trips and the point where it resets, prevents rapid on-off cycling. No, NC, normally open and normally closed contact behavior in the resting state. Minimum stimulus. Form CAE changeover, contact with a common terminal switching between no and NC. Failsafe, designing the circuit so a broken wire or failed device puts the system in a safe condition. Float switches, how they work. Many floats contain a tiny mercury-free tilt capsule, or a magnet that actuates a sealed reed switch when the float tips. The cable-mounted styles are simple and inexpensive. Rigid stem styles guide the float on a rod for repeatable action. Deadband comes from float travel. A longer tether or multi-float arrangement adds more separation between pump on and pump off to stop short cycling. Floats are great for clean or mildly dirty liquids, lift stations, sumps, and portable tanks. They don't need power to the sensor, only the circuit they control. Tuning fork switches, how they work. A small piezo driver makes the fork vibrate. When liquid covers the fork, the vibration frequency and amplitude change. Electronics detect the change and toggle a solid-state output or relay. Tuning forks shine in foamy, turbulent, or sticky surfaces where a float might hang up. They ignore most buildup, tolerate splashing, and can be mounted from the top side or in a small nozzle. Many offer selectable wet fail or dry fail modes, so you can choose which state is safe if power or wiring is lost. Safety snapshot, field pro habits. For overfill protection, use a high-high switch with fail-safe logic. Choose the contact action so a cut cable reads as an alarm. Add a bright pilot light and an audible horn. Keep low-voltage control circuits isolated from pump power. Use a control relay or contactor. The switch should not carry motor current unless it's rated for it. On hazardous or corrosive liquids, use the correct wetted materials and consider plug-resistant fork designs or guided floats. Selection, mounting, and testing tips. Pick by liquid and behavior. Floats excel in clean water and wastewater. Tuning forks win where foam, turbulence, or buildup are problems. Mounting for floats, leave clear swing space. For tethered floats, measure cord length to set the deadband you want. Keep the cable away from obstructions that could snag the float. Mounting for tuning forks. Install so the prongs are horizontal for the fastest response. For sticky or heavy slurries, choose high vibration or short fork models when available. Deadband control. For pumps, use 2 points. Pump on, at low level. Pump off, at higher level. With one float, use tether length. With forks, add a separate pump-off switch or use timer logic. Commissioning check. With power off, identify terminals, COM, NO, NC, or electronic output type. With power on, lift the float by hand, or cover the fork with the process fluid or water in a cup for a bench check, and verify the pilot light or input changes state. Nuisance trips. If foam or waves cause flicker, add a short on delay in the controller or pick a fork with built-in delay. Tiny history moment. Before solid-state sensors, plants relied on floats and sealed tilt capsules, simple, rugged, and everywhere in water, wastewater. Vibrating fork switches brought electronic reliability to places where floats struggled, cutting down on hang-ups and false alarms. Takeaways. Floats are simple, cheap, and perfect for many clean or mildly dirty liquids. Deadband comes from movement. Tuning forks detect liquid contact by vibration change. They handle foam and turbulence better, and offer smart fail-safe modes. Choose contacts and logic for fail-safe behavior, and separate control from motor power. Commission methodically, right device, right mount, deadband set. Verify indication. Outro. Thanks again to Tony Kuphaldt and the open source community. Next up, level switches 2, paddle, ultrasonic, capacitive, and conductive for trickier applications.